Hi guys, today we're going to do symmetry with respect to the y-axis. So we're given an equation, say y equals 2x to the fourth power minus x squared plus 2. And we're asked, does this equation have symmetry with respect to the y-axis? Well, what does that even mean? Well, I drew a little sketch over here on the right. This is not a representation of the equation over here, but just an equation that does have symmetry with respect to the x-axis. So you can kind of see what symmetry is. Okay, so this is the x-axis, and if we were to flip the top part of this curve over onto the bottom part, they would fall exactly on top of each other. So that's symmetry with respect to the x-axis. And here we're talking about symmetry with respect to the y-axis. So what we mean here is quite a similar thing, but going in the opposite direction along the x-axis. So something like this. Okay, so if we were to draw a line, which is already there in the form of the y-axis, but if we were to draw another line just to make it explicitly clear on the x-axis, if we were to take any point on this side of this curve and flip it up onto this side, we would get a point on the curve again. Any point here, if you flip the x and y coordinates, you would get a point on the other side. And this is true. If this is true for every single point on this curve, then we say that this curve has y-axis symmetry. Now, if you saw the visual picture of a curve, you can see now whether it has y-axis symmetry or x-axis symmetry. But how about if we're just given an equation like we're given over here, and we're asked, does this equation have y-axis symmetry? Well, there's a way to test for this without having to sketch a graph. Okay? And the way you do it is, everywhere you see, for every coordinate x and y, you replace the x with a negative x, and I'm going to put this negative x in red so it's clear. Okay, and y stays the same. Okay, so if we were to continue and go about replacing every x with negative x and leave all the y's the same, we would get y stays the same equals 2. Everywhere you see an x, put the x in parentheses, negative x. Actually, let's stick with putting it in red. To the fourth power minus negative x squared plus 2. Okay, so I put the negative x's in red so that you see everywhere here that we see an x, we replaced it with negative x. And now let's simplify this. Okay, so y equals, what's negative x to the fourth power? Well, any negative number to a even power is a positive number. So this is just going to be 2x to the fourth power, right? Minus, what's negative x squared? Well, again, any negative number or variable to an even power is positive. So this is just going to be positive x squared plus 2. Okay? So now I want you to take note of what we got here, because what we got here is exactly what we started with. And if this is true, In other words, after we replace every x with a negative x and then we simplify, if what we get, which I've circled here in green, is exactly equal to what we started with, then we can say that this equation has y-axis symmetry. Okay? So that's the way to analytically check whether an equation has y-axis symmetry. And this picture over here is just a representation of an arbitrary curve that has this y-axis symmetry. So this would be the visual of what we did over here mathematically and analytically. Okay, so I hope this was helpful. If you also want to learn how to test whether an equation has origin symmetry and x-axis symmetry, make sure to watch those videos, subscribe to the channel, and watch all the other math tutorials. Till next time, have a great day.